Okay.
So, where are we?
We are a bit lost, at least one of us. So we're discussing the test, which was not testing the thing we wanted, and how to make the test reproduce the case we are changing. So you did some changes to the code, and you created an artificial function that only raises an error. And when you started explaining it, my connection got completely
I
destroyed. So
remember.
my question for now is, like, what does this thing in function do that wasn't doing the previous text? Uh, like, why is this a better reproducer? Well, why
Uh,
is this a reproducer?
okay,
Why
yeah.
that
I
the
guess
previous thing
that's the
was not?
problem. It's not really a reproducer. It's like a demo to show what's happening.
Hmm.
Right? It's not a proper test.
Yeah, I understood that, but yeah, I will, even if that's a demo. Okay. Oh, like that. Huh.
Okay, so let's look at the test. Where is this? RPM Python at. Okay, so it's not a test. It just shows what's happening. So let's go through the current. So well, through the new test.
All right.
Then maybe we can revert and go through the old one and see what that did.
You can see it in the diff, the old one.
Yeah, but not very well.
Okay.
uh, okay, so we import interpreters, which is like an internal module for now because of political reasons. Import our RPM, then we raise an error and basically look at what the error is, right? So
Yes.
this should raise RPM's exception type, this PyRPM error,
Mm-hmm.
right? What we do then is we create a new interpreter, legacy, because we don't have a bunch of new stuff enabled in RPM, and
Mm-hmm.
then run this bit of code in it. There's an if true to handle this indentation, and this is the code we run. It's the same thing, right? So we basically print out what this PyRPM error is, right?
Mm-hmm.
And then we do it again, right? So ideally, what we want, so what we started with, without an isolated module, would be a state where all these exceptions are the same, because the module is loaded only once and then shared across all of Python, right?
Mm-hmm.
Where we want to get is this interpreter's exception is different from this interpreter's exception, because they have some state that doesn't really mix well, so this one and this one need to be different. But of course, they should be isolated, so when I removed all this interpreter stuff, that shouldn't affect the error in the like main interpreter, right? So
Mm-hmm.
this one and this one should be the same,
Yes.
and this one now should be different.
Mm-hmm.
The problem we're getting is that these two first ones are different, and then we get an error. PyRPM error is null. That's the system error in here. Right?
Yes.
So that's a problem. Let me try something else as well. Let me put this try except in here and see what that does. Failed again, of course. So now this first line is coming from the main interpreter. The second line is coming from the sub-interpreter. The third one is coming from the main interpreter again. Let me write notes there, right? So
none is the print result.
No, we don't want that. Oh, or well, that comes from the print.
I did not remember why we printed, but then I realized that if there's some different error, it actually gets stored in the result. So it was helpful when we were creating the test.
Right. So this is the sequence of actions, and it is this way because we have a shared module state, but we are treating it as if it wasn't shared, right? So all of our code is in the process from transitioning between a shared module state and a state that's specific to each module, right? So right now we have this we have this static pointer, right?
Yes.
Which can only point to one value, and all the module instances share this pointer, right? But then each of our module initialization function does what it would normally do in the new world, which is create a module with its own state, because it has this tells Python to give it this much memory for the module state. So each module object will have its own module state, but then it takes a pointer to this specific module state and puts it in the global pointer, right? So all of the modules will basically use the most recent module's state, right? And of course then we have the deallocation function, which will clear the module state somewhere. Oh yeah, it will clear
all of the pointers.
And then the module object will be deallocated, so the module state itself will be freed, but apparently its memory doesn't yet get reused. So we see the null in this space.
Okay, so that's why we see a system error, because this global module was deallocated by the sub-interpreter, which was putting its state into this global variable global state.
Right.
I
So
think I understand.
all the modules have their own state, but they
Yeah.
all use the most recent module state because of the global pointer.
Mm-hmm.
So the global pointer,
Because
we need.
yeah.
That's what we're getting rid of right now. If we look at the history of the commits, they also say get the state in blah blah blah, which means we get rid of the global pointer, and instead of that, we use module state from object and give it some object, so it gets the actual module state from some of the object's modules, with some of the module's objects.
Mm-hmm.
Right, and as soon as we can get rid of this global pointer entirely, our modules will be isolated.
And we'll see that in the demonstration code.
Well, currently the demonstration code, where is it? The demonstration code uses the global pointer. Right? If it used the module object, like if it did, how's that done? I forget. Well, let's look at this one. No, it should be in the header file, right? RPM. No. What is the header file? RPM system. That's it. So RPM mod state from module. So this is a module level function. Let me actually paste, copy the whole signature. So this function will take the module object. This is a module level function, so it'll get the module as the self argument. And if we just call this mod state, shadowing the name of the global pointer, passing an argument, not defining a function. Alright, let me save this to some file for later and reload. Right, so now we have the main interpreter, the sub interpreter has a different ID, and then the main one has the old value. This is what we want.
Wow. Yes. Wow.
And
yes.
this is exactly the change we've been making everywhere. Right. You're smiling, so I guess it makes sense now.
It does. It does. I'm glad I can see it reflected in the code. Like the previous test did not show it to me, or I was not to test like the code we were using to demonstrate the issue.
The demonstration. So let's maybe put it in here to So that leaves us us where we were a month and a half ago, applying all of these changes, right? So I
Yes.
should look at one of my multi-phase.
I think it was ABI free branch.
Yeah. Yep, that's it. Okay. So we ended with RPM TE pi, and here I see then there's RPM TS dot pi, RPM verse spec, and then some cleanup. Okay, so what does this one do? It removes the pointer, which is really nice in C. You can remove the declaration, and then anything that uses it will just fail to compile. And then we get the mod state wherever it's needed, right? So
Yes.
let's go to rpmts.py and go through the process. rpmts. These names are very confusing. So I remove this and make it and get 7 errors or whatever, and that just shows the places that need to change. So the way, well, there are errors about a missing mod state variable, so we need to add one. We add one in a function scope, and we need to get the module state somehow from something we have. So here we have an RPM object, so it's RPM module state from object. Same here, same here. This one will be a bit more interesting. The others don't look very interesting. Then there's a header where we have this macro that checks if an object is of the RPMTS type. So what I did here is check if the RPMTS type can be subclassed, because if you can subclass it, then this is not a good check. Let's look at where that's defined. Should be somewhere in the RPMTS file near the bottom. Yeah, in the flags. So it says rpm.ts is the name of the type, and the flags are uses default flags. It has garbage collection. It's a valid base type, so you can subclass it, and it's an immutable type. And this is a problem, because whenever anything will call rpmts object check, it will fail to return true for subclasses. Apparently I did not check that when making this pull request, when making this commit. I don't know if we want to fix that for RPM, because apparently it works now. How much do you want to improve the RPM bindings overall, rather than just convert to the new API? So if you want, you can add a to-do list item, and let's do that later, because I see this just does the same thing.
Yeah, I'm all for improving RPM, but I still don't understand why is a problem in subclassing, or like what will happen then.
Right, so this gets the type of an object. it assumes that this v is a PyObject pointer, and it gets the type field from the C structure, and that's the type of the object. So if this is a subclass of RPMTS, it will have a different type.
Okay.
So you cannot check like this. Right? In Python, you can write if type x is, I don't know, int, do something, right? And this means that x is an integer, not a subclass of integer, which is usually not what you want.
Can you just enter the yeah, I see VPS3 CZ header covering this. Okay, that's perfect.
They have a watermark now.
Yeah.
I'd say we wouldn't write this in Python, right? Unless you really wanted this, and then you'd put in a comment saying, you know, we don't want subclasses. So that's exactly the same thing in C. Where's the
okay, so that in Python we use is instance, and it goes up the tree.
So in C you would use something like this. Subtype, no. PyType is subtype, or PyObject something. Type check. Yeah, this is the one. Alright, try non-zero if the object O is of type or subtype of type. This does not do the same thing as a subclass, because you can modify what a subclass does in Python. This is the one to check if you want the same internal memory layout. So if you want to use the object in C, you need this strict check, which can only do single inheritance and it's more limited, but it gives you the proper guarantees for C. Right, so anyway, that's an unrelated bug that you might want to fix later if you want. Let's ignore it now. So here, instead of this define, we define a function. So, do you know about static inline functions? I don't think we've covered those, have we?
Static inline.
Right.
I don't remember. So it's private to this function?
Yes, static means it's private to this file. And this is a header file which is included textually in the C file that you're actually compiling, right? So this function will be repeated in every C file, right? Normally, if you don't do static, then it will define a function like at some point in memory, and all the other code will jump to that function to execute it. This one is just basically repeated in every file, which is good for little functions like this. It's exactly the same thing as define does. Well, not exactly, but it's similar in this way to what define does. The advantage to functions is that you get types. So the compiler helps you, you know, in a very limited way that C does types, that things are actually correct, right? And that this is actually one variable, right? That you didn't put like two comma separated things in this V and stuff like that, right? So it's, if you can replace a define with a static inline function, it's usually better to do that. Sometimes you cannot, but it's usually better to do it.
And defines macro.
Yes.
The thing that's getting deleted is basically a textual template that will be
Yes.
like you can just put anything there in the instead of v, and it will just get replaced, right? So
Right.
function is a bit smarter.
Function is a bit safer. Now with macros, you need to be very careful. For example, I still have this v in parentheses. You need to do that for macro arguments. Otherwise, this arrow or even this comparison might bind more tightly to than something in this v. Right. Well, let's see. Probably better to. So if you do rpm_ts object, and do, I don't know, a dot b or a minus b, right? Then with this, it'll get expanded to this, which is great. If it did not have the parentheses around v, it will get actually replaced with this, and the OB type will only apply to this b. Right? This is such a foot gun, right? This macro will work perfectly for a simple value, but then you put in something benign like a minus b and it just blows up in a weird way, right? Another thing that you need to watch out for when defining macros is when it's a very complex macro and it does more things, and it includes the v several times, right? Because then if somebody calls it with something like that has a side effect like a equals b, or even a function, well, then your function gets called 2 times. Right? So that's also something to take into account when defining macros. And those two are the main reasons why you should always use static inline functions if you can.
So why in the static inline function on the row 16 you keep the parentheses around v?
Because I'm lazy. Oh, another reason to use functions is they're easier to work with if they're big. Like if it has 5 lines, the macro would need backslashes at the end of the line to continue the lines. Function just is normal C code and it gets syntax highlighted properly and all that, right? So function's good, macro's bad. Sometimes you need macros. Not in this case. Anyway, so we get the mod state from this object, which, if there's no module state, then it's not an rpm_ts object. And we ignore any error that might have occurred because it's the wrong kind of object and return 0. Otherwise, we do the type check as before. Right? And now for this interesting thing, probably want to apply this and look in the editor. So this is in rpm_ts callback. That'll be fun. Just RPM-TS callback. All right. So callback, just from the name, I guess it's a function that gets called from some C code, right? I have no idea what this does, but let's imagine that RPM is a low-level library that installs your packages, and it needs to update 700 files for a package, and if you're coding DNF on top of that, you want to see a progress bar, right? So RPM wants to call your progress bar function for every file that gets installed, right? So you tell the RPM library, please call this function with this argument. In C, the argument is usually a void pointer, which you can point to anything, and then you can, interpret that memory, and that gets called, right? So when you're writing a Python binding, you need to put the Python function in that argument, right? So, so this takes the argument as a void pointer. It tells you what happened, how much of that happened, what's the total, so it's probably is for a progress bar, and then it has some callback data. So this is probably the so this is probably where you put in the argument, where you put in the Python function. Like we stash it in and add some memory, pass it to RPM, and then you get it back and you unwrap it and you can call it as a Python function, right? So there's some cbinf RPM-TS callback type S. Well, that's some generic type, I guess. Maybe it's even defined by the wrapper, I don't know. But well, it reinterprets it as some structure, and then it can look into that structure, right? So this is how you do callbacks. It's not type safe. You just get a pointer and assume that you got what you put in, right? There's a callback in there, which apparently is a Python object, and if it's none, then this does nothing. There's another Python object, probably, yeah, some Python object called TSO. It probably stands for something, and it's an error to leave it out if there's a callback, right? So then we get an error. This is rather dangerous from a C callback, because if the callback function gets called several times without any Python code in between, this will raise multiple errors, and some of them will be lost. And I'm not sure if we have exception group API to handle that case, so it's probably the best we can do. Assuming that this return null will then be somehow handled on the RPM level, and it'll signal an error back, and then we can handle the exception. But that was already there. No, it wasn't. Oh, we're adding that. Okay, anyway, TSO apparently is some object from the RPM Python library, so we can get its module state. Right? I'm not sure what kind of archaeology I did to figure that out. but apparently if it's not null, then it needs to be our object from which we can get the module state. So we're done.
Mm-hmm.
Right. So let's go to the next one. RPM ver. So ver probably stands for version. This is the same thing again. So there's a mod state pointer. There is ver object check. And that need to yeah, there's a check here. Again, this is the same thing as before, except here we cast v to PyObject. Here we didn't cast v to PyObject, which is weird, because the caller would need to do it. Otherwise, you cannot get its OB type. It's interesting. Anyway, when we have a static inline function, it takes a PyObject, so the caller does need to cast it. And yeah, that's the same thing as before. By the way, for a detour, this is a comparison function in the C API. It gets two objects, which might be generic PyObjects, and it gets an operation like the comparison operator. It makes sure that it has two RPM ver objects, otherwise it returns not implemented. And then it looks at op, which is LT or LE, and so on and so on. And this function apparently gives you an int 0 or 1. Oh no. This function gives you a comparison result in C, so a negative value, 0 or positive value. That tells you which one is bigger. That's compared to 0, and then you use pybool from long, because we don't have pybool from int, and ints get converted to longs automatically. So otherwise there's not really much to see in this commit. There's a conflict
here in this file.
Somebody changed it in the meantime. Good for them. Okay, RPM ver pi line what? Oh,
somewhere in the end.
Oh no, header file.
No, the header. Oh.
So it's a short file. No, not TS ver, RPM ver. Okay, so the define changed to use PyObject type check. That's the
I've
one
heard
I was
about that
telling
one
you
today.
about, right? So instead of the old one, we used the new one. So we did the old one in here, pretty much the same thing, except the cast is now here. So we do this instead. Space here. Right. And that should solve the conflict. Oh. I hate being in a subdirectory. Okay. Let's look if that's right. So yeah, it tests here, and then this one is the same as before, except RPM likes tabs. Yeah, the indentation style of RPM is really nice. They indent by 4 spaces, but if you have 8 spaces, those get replaced by a tab.
Best of the two worlds.
Yeah. How interesting can these things get, right? So specpy.c. So the same thing there is as before. Now here there is some helper function that only takes an RPM level object. So we have no Python object here to work with, which means we need to change the helper function to take something, and it's probably best to take the module state, because anything that works with Python already has it. It's static, so it can only be used in this file. It's not included anywhere else. So we just change all the calls, right? So there's one here. So we get the module state and pass it on. This one is the same thing, so we get the module state and pass it on. Applied. Now, okay, this one is about removing unused check macros. Apparently there are some check macros that nothing uses, and since these are private headers, we don't really need those check macros. If anybody needs them, they can use the example from the other files. I could have expanded these to static inline functions, but nothing calls these and nothing tests these, so I don't like to check in untested code. Or do we still have these? Archive py.h. There it is. Fine. There we go. So I should probably try to make this and see if any of those are still needed after removing them. So let's do that. Cherry pick this. Removed, and let's see if it still builds. Yep, still builds. Do we have any more? Nope, that's all of them. So the way I prepared this commit was probably remove them one by one, and when one was needed I converted that to the inline function and then rebased it to the commits for the proper file. Okay, next one, remove global state. So this is the final commit.
Yay.
And it removes the global pointer. It also removes the restriction that you can only load the module once per process, and it removes the global pointer, so this is now a local variable for init as well. I think this will conflict a bit, but
Yes.
we can deal with that. Nope.
Oh.
Nope.
Okay.
Okay. Weird. I think this would...
It is.
Oh, it's already removed. We moved it somewhere else, right? No, we already removed that entirely. Ah, right. We already removed that.
Okay. So what did change with the cherry pick? Can you show the commit? That was applied.
2 lines.
Okay. Okay.
And we should probably do something about this init and add type as well, because it says it does things only once per type per process, which is not correct anymore. Let's see if we can build and test this. Yeah, everything works. The test or the demonstration works as before. Now we intentionally leak a reference to type. That shouldn't happen anymore. So this says let's do it right as if we haven't just leaked, so the comment is outdated, and let's see if that still works. Okay.
We are only running Python tests, but that should be enough.
Yeah, we're only changing Python code, right? Or the Python bindings. And I don't know how to check for memory leaks in an extension, especially not in these AT tests. You definitely should remove this test, because this is private API that's subject to change. So that's one thing to do. So I've only checked for reference leaks in Python itself, not in extensions. I think there is some kind of ref leak checker. Show ref count. Output the total reference count and number of used memory blocks when the program finishes. So this will tell you how many objects are still in use. Python it's show ref kind. This does nothing, because I don't have Python debug. This, okay. How does that not do what it says in the new REPL? Haha, that's that's a bugged report.
Uh-huh.
So report that. My to-do list is too long, but I'll put it on there. Okay, so that's a bug in the new repo, not the first or the last one. So we need to get Python debug into the container and somehow pass x show ref count to each test. Right, so is this the proper Docker file?
Yeah, it should be.
Python 3. Does Python 3 devel include Python 3 debug? Probably not.
It
right?
does not.
So Python 3 debug, and then somehow the tests are run. Is that in this file? RPM PyTest. Where's that defined? Local at.
It will be local. Yeah, it's local.
RPM test. Set up an RPM PyCheck. Just clean up. RPM tests. RPM PyCheck. RPM PyRun. Got EOF to test Py. Python.
Yes.
Aha. I don't know where Python is set. Where is Python set? Can I just say python-debug since we're on Fedora? Oh, we're getting a new container.
42.
Let's see what breaks.
Someone is in the future.
Have the background.
Yeah, I see. Oh.
Yeah, that
Yeah, that
didn't
makes
really
sense.
work.
That makes sense.
So what happened here? Python 3.13 debug. No such file or directory. Oh, I don't have it installed locally, do I?
But you just run. Python debug. Would that?
Oh. Not DNF. Not RPM.
I'm not sure, like, would it be like Python 3 debug when it's main Python on this version of Fedora rather than 3.13? Do we provide versions debug?
It's Python 3.13D. Oh, of course, it uses the upstream notation, which makes a lot of sense. So let's update the hack. No. Yeah, something's wrong.
Ref count is too small.
Ref count is too small.
Enable trace malloc to get the memory block allocation trace back.
Okay.
Yay.
Yeah. So this is wrong. So the demo actually works, but then we get a debug assertion. All right. So that's something we'll get to later. Right. So what I did here is to encrypt the type, which means make it not increase the reference count so that the one extra decref doesn't blow up in the debug mode. All the tests fail. Oh, this one didn't. Oh, this one. All the tests fail because they have extra output.
Yeah.
Which is
expected.
Expected. Apparently we have 526 references in this test. 500 in that test. And we'll need to dig into that somehow. But for now we're out of time. So let's do that next week.
Great. Next week on Thursday, or would you prefer another day?
Next week on Thursday, unless something else comes up.
Hopefully not. So 22nd. Oh.
See you then.